Stack view. According to the documentation, a UI stack view is a streamlined interface for laying out a collection of views in either a column or a row. And that is a very typical thing you're going to want to do in laying out your interface. So essentially, it is a UI view. It's a subclass of UI view. So it inherits all the properties of your responder, UI view, and you basically tell it which axis it's going to be. Is it going to be a horizontal, which means x-axis, or a vertical, which means along the y-axis? And you add this property called arranged subviews. And an arranged subview is just a bunch of views that the stack view arranges for you along that axis. So let's go ahead and get started. We are going to create a new project. Single view app, UIStackview practice, and Swift. Okay. So there are two ways you can do your stack views. You can create them using Interface Builder in a storyboard or in a zib, or you can create them in code. We're going to be starting today in the Interface Builder, and if we have time, we'll get to code. Otherwise, maybe we'll come back and do a follow-up. But really, let's just go through some of the basics here. So we can drag out a couple UI views. Actually, let's start the other way. Let's bring out a stack view. Give me a horizontal stack view. So you can see that the stack view comes out. It becomes a subview of the view controller's view right here. It doesn't really have any background color. It doesn't do much until you start adding things to it. So in Interface Builder, the way you add these arranged stack views is we'll add some labels. You can either drop it on top, or we can drop it in along with this in this document outline here. So we'll put in our first label, and there we go. Now, currently, we don't have enough information for the stack view to position itself. The stack view, at an absolute minimum, needs to know its X and its Y coordinates as to where it goes in its super view. So to keep this as simple as possible, we're just going to go ahead and we're going to align it to the horizontal center and the vertical center in its container. Okay, you can see all of our warnings have gone away. And let's take a look in the simulator. Now, obviously, there's not a lot of advantage of using UIStackviews if we're just talking about one view, right? Because its whole purpose is to lay things out along an axis. But we're going to build up. We're going to work up towards it. Okay, so at least it's working. We can see that that works. We have our UI label centered in the middle. Now, what we can do is we can add a second label to our stack view. And let's see, this time we will add it via the document outline over here. All right. We have two labels. We'll call this one label 2. And we're going to give it a background color, excuse me. And the first label, we'll get a different color just so we can see what's really going on here. Okay. So we have a UI stack view that has an X and a Y position, which is the center of the view controller's view. Its and it's along the horizontal axis because that's the one that we picked. So you can see that it's laying our two views out horizontally. Its distribution is currently fill. And what that means is that the stack view is going to lay out its views and it's going to try to fill the entire space based on the intrinsic content size of the views inside of it. And this idea of intrinsic content size is really, really important for understanding stack views. Like, to understand stack views, you have to understand auto layout, but you don't really have to understand it to the degree as if you're laying things out by hand, because it is supposed to simplify it for you, but you really need to understand intrinsic content size. So some, but not all views have an intrinsic content size. And all that means is it's a type of view that knows how big it should be. Okay? Now, a label is one of those types of views. A UI label knows how big it's supposed to be based on the font and how the label is going to render the given font, given the user's preferences for font size and the type of font and the font size that you've selected. It can do all those computations and give you the intrinsic content size. So it is intrinsic to this label that it is this wide, which is just a little bit wider than the text, and this tall, and it's just a little bit taller than the text. And having the background color makes it a lot easier to see. So the intrinsic content size of the word label is smaller than the intrinsic content size of label 2. Okay? Now, you remember that we didn't have to add height and width dimensions. We only had to constrain 2 dimensions of our stack view. We had to give it a X and a Y position. We didn't have to tell it how big it's going to be. You can do that, but you don't have to. If you only give it an X and a Y position, UIStackview will take account of the size of all the elements of all the views, all of its arranged subviews inside of it, and it will determine its own content size. So in this example, it's centered. We have 2 labels with no space in between, and the system will go ahead and figure that out for us. So let's quickly bring that up. There we go. This is a stack view that is centered in this view controller's view, and it has these 2 things laid out nicely. Okay, so we can add a bunch more. Why don't we add some this way? We'll add one up here. Test, label, 1, 2, 3, 4. And you can see it nicely lays things out along the x-axis. All right, let's take a look at some of the notes we have for today. So it's a UI view subclass, check. Simplifies layout by adding constraints. Like, if you think about it, what would you have to do before stack view, or if you weren't using stack view, to lay these out? You could certainly do it, but to get these labels lined up next to each other, centered horizontally and vertically, it would be more work than this. So when you get to more complicated layouts, it can be significantly more work. So it does really help laying things out. And Apple recommends that whenever possible, you should do your layout using stack views. So it creates rows and columns along an axis. And at minimum, it needs to constrain the X and the Y position of the stack view. You can give it more constraints. You can tell it how wide it's going to be. It will do that, but you don't have to. iOS will add up the intrinsic content size of all the arranged subviews, and it will determine the size of the stack view. Now, you can see that the stack view has an array of arranged subviews. It has 1, 2, 3, 4 right now. And typically, when you have subviews of a view, What the order does is it determines which will be drawn on top of the other. With arranged subviews, changing the order changes where along the axis it will be drawn. So label 2 now, the blue one you can see is the last in the array, and it's the last furthest to the right over here. We are going to drag it up, and because it's the first, it'll now be the first in this array. So that's nice, and these are all dynamic. That's a dynamic property that you can change at runtime. You can tap a button and swap the position of arranged subviews if you need to. Let's take a look at changing the axis. So we are currently at horizontal. If we change to vertical, just like that, we're going to get a column instead of a row. We can take a look at alignment at this point. So currently, you can see everything looks like it is on fill alignment. So everything is completely filling the space. Leading is going to line things up along the leading edge, and it's going to reduce the size of all the elements to their intrinsic content size. So at fill, it was completely filling the stack view with the content. When we switch to leading, the elements are using their intrinsic content size. So label 2 is this big, and it's not extending all the way over. And they're all aligned by the leading edge. And we also have center, which does something similar, still the intrinsic content size. And you can see, this is a great example. You can see that the stack view is tall enough to fit all of the labels, and it's wide enough to fit the intrinsic content size of the largest label, or the largest arranged subview, right? And then again, we can have trailing. So fills it all the way, and the other ones, all the other options, reduce the elements to their intrinsic content size. Or if you can have more constraints on a view, it will respect those, and then it'll align it according to these like 3 typical ways. So we'll go back to leading, and then we have distribution of fill weakly, proportionally, spacing, centering. We are going to come back to these. Let's go back. Oh, and then we'll do spacing. Spacing, basic spacing is pretty simple. It adds spacing in between each of the elements, and when it adds that spacing, you are going to recalculate the size of the stack view itself, because it takes the stack view size is a combination of the arranged subviews, intrinsic content sizes, plus all of the spacing. So this is a really easy way to control spacing right here. Okay, let's go back to horizontal for a minute. And we're going to look at distribution. So the only time that the stack view doesn't care about intrinsic content size is when you have a distribution of fill equally. Now, here, let's take a couple of these out real quick, just so we can see what's going on. Okay. Before, we had fill. And fill just fills the space using the intrinsic content size plus any spacing to determine the size of the stack view. Fill equally essentially disregards intrinsic content size. What it does is it fills each arranged subview is going to be the same size as every other arranged subview, and if possible, And in this case it is, because we have no width constraint on the stack view. It will give everything equal size. And what it tries to do is it tries to take the largest intrinsic content size, which is test label 1, 2, 3, 4, and it makes every other arranged subview as wide as that. So if we put in another one here, and we make it really small, like a little winky face, little winky face gets as much room as test label 1, 2, 3, 4, because it's the fill equally distribution, the distribution of the arranged subviews. If we go back to fill, the winky guy only gets his intrinsic content sizes worth of space. Label 2 gets its space, and test label 1, 2, 3, 4 gets all the space that it needs as well. Fill proportionately basically fills each arranged subview proportionately to its intrinsic content size. Let's see, what's a good way to show equal spacing? Okay, we're going to have to do something a little different to show what equal spacing is going to look like. So let's start bringing in, actually, no, before we do that, let's do a couple things. Let's now give a stack view an explicit width. So we're going to pin, okay, let's actually start by clearing the stack views constraints. Again, we're going to align it vertically, so it's going to stay in the middle, but this time we're going to pin it to the edges of the super view, leading and trailing. So it has the stack view is now going to have a fixed width, and it'll have a flexible height. I think I just screwed that up. Let's try that again. So again, we're going to pin the leading and the trailing edge to the super view. Okay, there we go. Now things are a little bit different now. We have to take a couple of different things into account. So let's go back to the stack view itself. Okay, so here's what's going on now. The stack view is going to be as wide as the view controller's view, no matter what, because we set a constraint that tells it that. Now we have 3 labels that may or may not be the same width. You know, the intrinsic content size plus the spacing is probably not going to add up to the exact width of the view controller's view anymore. So what you have to be able to tell it is, if we have to stretch, right? So if these 3 labels are not wide enough to accommodate all the space, which one of them is going to stretch out to fill the additional space? And right now, we don't know. I forget the word. It's not incomplete. I'll have to look it up, but there's a word for it. It's ambiguous. So it's ambiguous as to which of these views should stretch. And the way we solve that is we look at the content hugging priority. And basically, the higher the content hugging priority, the more that the view wants to stay at its intrinsic content size. So you can see that winky face guy here is staying at its intrinsic content size, as is test label 1, 2, 3, 4, but label 2 is stretching out. Now currently, all 3 labels have a hugging priority of 251, which means it's not obvious to the system which one should stretch. So we have to actually tell the system which one should stretch. So if we want it to be winky face, we're going to lower its content hugging priority. And just like that, when it needs to stretch, label 2, test label 1, 2, 3, 4 will remain at their intrinsic content size, and winky face guy will stretch as big as he needs to go. Now that's going to hold true whether we are in portrait or landscape. like it can get really huge, or just a little bit like that. So when you do pin the stack view and you do give it an explicit width or height, you need to be thinking about this kind of a situation. Now, the reverse also holds true. What if we have a super long label? Okay, now we have 3 labels, but they don't fit on the screen, right? And it's a very similar situation. You have to say, we have 3 labels with the content compression all at 750. The content compression is how hard does the view want to fight being compressed? Or in this case, the way a label gets compressed is it's truncated with the 3 dots. So if we're saying, okay, we're cool with label 3 since it's taking up so much room being compressed if there's not enough space, we'll drop this one down to 749. And the other 2 are going to be fine, and we're going to get rid of our warnings. So let's take a look at how that looks now. Label 2, winky face, are both at their intrinsic content size. They both fully show. But label 3 truncates with the ellipsis at the end. So because its content compression resistance priority is lower than the other 2, iOS knows to shrink that one. Okay. So that's labels, right? But we can do way more than labels. We can do any type of UI view subclass we can add in here. So let's get back to that. Now, let's add something else that has an intrinsic content size. Let's get a picture. Let's get a waterfall picture. Sweet looking waterfall. It's ginormous. It's kind of what I'm hoping for. Okay, so we're gonna get a waterfall pic. Right over into our asset catalog. All right, now we're going to bring in an image view. Now, when you first bring in an image view, it doesn't have an intrinsic content size because there's no way to say how big this image is supposed to be. As soon as you add an image, though, now it has an intrinsic content size. All right. And here's an example where you might want to give a particular view a size constraint. Let's see what's going on here. You might want to keep this view at, say, 100 pixels. So now that view is constrained to be 100 pixels. And we're going to add our waterfall. That's not good. Okay, there we go. Okay, this is going to bring up a couple interesting things. So the intrinsic content size of label 2 is, it hasn't changed, and our wiki face hasn't changed, but the UI image view is intrinsically this tall, however tall this is. Okay, so we're going to go back to our alignment and let's see, let's mess around with this a little bit. So here's a good way to illustrate how the alignment property works with the vertical. We have a very, very tall view because intrinsically this thing is huge. If we go to fill, the label is going to become as tall as the image view is, which is very tall, along with the winky guy. If we go top, it's going to align itself to the very top. Center, like this, but it's going to keep its intrinsic content size. And baseline is going to align the first baseline of the label with the image. All right, so let's get rid of this guy for now. Say goodbye to the waterfall. And let's bring in a simple UI view. All right, we'll give it a color. Okay, now, the interesting about the UI view is that it does not have an intrinsic content size. Okay, so we can drag it around an interface builder and kind of craft it to the size we want it to be. But that's not going to work because it doesn't have a real size. That dragging it around an interface builder just shows a visual representation. So if you want to just have a plain old UI view, the way we do this is we're going to create a subclass of UI view. Test view. And then we're going to override intrinsic content size. And then we're going to return a CG size. We'll call it 50 by 50. Okay, so we're going to go back to our main storyboard. We're going to give our UI view a subclass of, what do we call it? We called it test view. Okay, so test view now has an intrinsic content size. Let's go back, run it again. But it stretched probably because, let's take a look at the content hugging priority. Yeah, so the content hugging priority of our test view, 250. Our label is 251. And, our label here is 250. So I think it's the arranged subview that comes first in the array. If there's two competing arranged subviews with the same content hugging priority, I think it's the first one that gets stretched out. We can quickly test that. Yeah, let's see if that works. Right. So they're both 250. So the winky face gets stretched out, and this time our test view gets our 50 by 50 size, which we set it at. Okay, there's a little bit more we can talk about here. Actually, there's some good examples too. Let's see, I think it's switch, no. Okay, you got to be careful because some types of views have an intrinsic content size in the X direction, but not in the Y, or vice versa. Let's check it out here. Okay. Okay, that seems to have worked out pretty nicely. So if there's anything else we can figure out here. Let's see. So we're okay. In this particular case, again, we're on the horizontal axis. Oh, okay. This is a really good way to show it. So we have the our UIView subclass is 50 by 50, and 50 is by far the tallest out of all of these elements. These are probably like, the labels are probably like around 20, the switch is around 20, this one's 50. So since our alignment is fill, these elements are going to take up all of the vertical space. If it's top, let's predict what's going to happen. My guess is that they're going to shrink down vertically to their intrinsic content size, which is around 20, and all line up along the top. Sweet. You can see that's how it worked. And then, of course, center and bottom. We can take a look at how the baselines work. So the first baseline of the labels, the bottom here, line up with the top of the other elements. And last baseline, the bottoms line up with the bottoms of these elements. So again, fill, fill, and fill. The alignment, when we have a horizontal axis like this, the fill talks about the vertical spacing, and the distribution talks about the distribution of these in the x-axis. So again, let's look at fill equally. And okay, we actually haven't looked at fill equally with an explicitly constrained stack view. So let's take a look at that. Now, this is a little bit of a different case than before. Because before we had horizontally constrained our stack view, every single arranged subview became as big as the biggest element. That's not possible here because we're constrained to how much space we have. So it tries to do that, but I don't think it had enough space. So the system is going to, if possible, make everything as big as the biggest element. But if not, as close as possible, and give all of the arranged subviews equal space, or equal fill space, basically. Let's make that even clearer. We can do a red, make our switch. Okay. Now, let's go back to our stack view. Fill proportionally. So it's going to, again, take the intrinsic content size into account. Equal spacing, we're going to go back to every single element's going to be its intrinsic content size, and then we're going to have an equal amount of spacing in between each element with all of the space that's left. So you're going to divvy up, you're going to place everything based on the intrinsic content size, and then any space that's left, we're going to divide it up equally into slices and use those slices to space things out. But we have a warning on that one. I did not notice that. Okay, let's go back and take a look. So we're fully constrained. I don't know what this warning is. Need constraints for exposition. So we have to add missing constraints for switch, test view. They'll add enough constraints to resolve this ambiguity. So what would it do? Yeah, it wouldn't help very much. Set horizontal compression resistance on that guy. Okay. Horizontal compression resistance. All right, this is a tricky one. I don't know what the problem is. Let's try to reset it and figure it out. We're going to clear all constraints. Again, we're going to put the stack view vertically in the container. Okay, so we have an intrinsic content size here, 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 and this one should as well. So let's say if things need to shrink are labeled to, if things need to expand, we're going to let label to expand. So we're going to give it a low content hugging priority. Exposition. Why would these need constraints for the exposition? It has to do with this subview right here. What happens if we give it an explicit width? It goes away. Yeah, for some reason, the storyboard is having trouble understanding the intrinsic content size of this view. Pretty sure that's what was going on there. Okay, so at least we know. And so the way I resolved that problem was I gave this gray view, I gave it an explicit width of, let's see, what did I give it? 152. And that was enough to resolve the issue. So let's see, let's go back to our notes. Looked at this, we've talked a lot about content, intrinsic content size. Oh yeah, this was a good article on Apple's developer site that talks about intrinsic content size. And I'll put this in the notes. Not all views have an intrinsic content size. For views that do, you can define the views with height and width or both. Here's some examples. So UI view does not have an intrinsic content size. That's why we gave it one. A slider defines only the width. So if you put in a slider, it only knows how wide it is. You have to, if you need the height, you have to give it the height either via a constraint or overriding in a subclass. Here's some stuff that we've worked with: labels and buttons, switches. Define both the height and the width. Image views, intrinsic content size can vary. And text views, you can read about it here. Text views are crazy. There's a lot of things that go into the text view. So I'll be sure to add this link in the show notes. Can have stack views be arranged inside of other stack views? So let's take a look at that. Let's clear everything out and we'll do something. So what we want to do now is we want to start laying out a little bit more of a complicated layout. So we're going to have, our goal is we're going to have a column of labels along the left and then a grid of switches next to it, just because we can. So I'm going to show you a little bit of a couple different tricks. We're going to drag out 5 labels, select all of them, And then we're going to tap this button down here, which is like a square with a downward facing arrow, embed in stack. Basically, everything you have selected, it will then embed that in a stack view for you. There we go. There's a vertical stack view. And it looks at the orientation of how things are laid out when you select them, and it guesses if you want a vertical or a horizontal stack view. If you want to change it up, no big deal. You can come back here and change it up. But vertical is what we wanted, so that's cool. And then what did I say? Switches, right? So we're going to have a grid of switches next to it. And the way we're going to do that is we're going to make two more columns. So I'm going to select two switches, embed them in a stack view. Two more switches, embed them in a stack view. Now, so it's a good practice to label your stack views because they do tend to add up. Column labels. Column switches. Okay, so now we're going to take our two stack views that are column of switches, and we're going to embed that as well in a stack view. Okay, so now we have a grid of switches, and we have a column of labels. We're gonna embed those two in a stack view. Okay, so things are shaping up already. We're going to take this stack view, and we're going to, let's see, this is a little bit arbitrary, but let's pin it to the top and the bottom, because this is so let's just double check here. This stack view is a horizontal stack view, okay? So we're going to pin it to the top, we're going to pin it to the bottom, and we're going to pin it to the left side. Okay, let's figure out what we have going on here. So we've given it, by default, we've given it a height because we pinned it to the top and the bottom. We haven't given it a width because we only pinned it to the leading edge. All right. So let's come over here and then you can go down and you can like go inside here. So we have a column of labels and we want to make those have a little bit more spacing. So let's give those some breathing room, 16 each. And let's go into our switch grid. And our switch grid is horizontal, so let's give 8 points of spacing horizontally. And then both of our columns of switches, we can give 8 points as well of vertical spacing. Okay. So back up to our stack view. So again, if we want to bring these up, we currently have an alignment along the bottom, so we can make this center. Okay, and our distribution is currently fill. So we can say fill equally, which let's look at why that happens. We have our switch grid, which has an intrinsic content size of whatever this width is, which is certainly bigger than the labels, right? So if we go back and we say our fill is fill equally, it's going to try to take the larger of the two intrinsic content sizes of its two arranged subviews, and it has exactly two arranged subviews. And it's going to take the width of the larger one, and it's going to make both of them that same width. Okay, so we're going to go to fill equally in this particular case. Wait, no, that wasn't right. We're going to make the top stack view fill equally again. Okay. And we can add a little bit of spacing here as well. We can add maybe 8 points of spacing to these. So this is certainly a contrived example, but let's fire up the simulator. If we needed a layout like this, this would not be trivial to do with auto layout constraints alone, right? And then because this supports resizing and this supports changing orientations, this would be a decent amount of work to do. And really for us, it was pretty simple. And no, we kind of just messed around with it, but you can imagine that we could then add labels to these switches so that we could know what they are. We could add other elements. It took us a couple minutes as opposed to possibly a couple hours to lay something like this out. So it's very, very helpful. Now there's more that we can do, right? There's new things with iOS 11 where you can add custom spacing between labels. That's something that we haven't really touched yet. But up until iOS 11, you could only have fixed spacing between your elements, between your arranged subviews. Starting in iOS 11, you can have custom spacing. Now, you can't do this with Interface Builder. You have to drop down into code in order to do this. But that's something you can do. And you can also encode, if you set one of your arranged subviews to is hidden, everything will be handled for you. Like, you don't have to do really any work at all. The iOS will update your entire stack view for you, and it can even animate the changes. So that's really, really nice. I think that's it for today, though. We may come back tomorrow and look at some more of advanced UIStackview stuff. We may get back to some drag and drop. We'll let you guys know on Twitter. And again, please let me know in the comments if you have any questions or suggestions. I'd love to hear from you. Thank you.